let's go over the review here. Okay. I'm just going to go through the whole thing up here. Okay. If you guys have questions as I'm going through it, stop me and ask questions. Okay. But otherwise, I'm just going to go through the whole thing here. Okay. So first 5 questions, we're looking at this diagram. First one just says name a line in this figure. DF. Sure, that would work. Okay. Remember, to name a line, we are only using 2 points. Okay. Do not name a line using 3 points. Only 2 points, and then we put a line over top. Okay, that's how we name a line. 3 collinear points. Okay, collinear means on the same line. So yeah, D, E, and F would be 3 collinear points.
I didn't even see there was 3. No, I'm talking about 3, 4, and 5.
Oh, okay.
Why didn't you see 3?
So 3 says our points D, E, G, and H coplanar. Coplanar means on the same plane. So we've got D, E, G all on this plane, and then H is above that. So no, they are not all on the same plane, right? So it does say explain, so we could say H is not on the same plane as D, E, and G. The number 4 says name a plane. Okay, well, we had 2 ways to name a plane. We had 2 ways to name a plane. Okay, one is if we had an uppercase script letter. Okay, we don't have that in this case. So the other way is to use 3 points on the plane. Okay, 3 points that aren't on the same line. So I could say DGE or GEF. Yep, that would work. Right, or GDE. Right, any of those would work as long as I'm not choosing 3 points on the same line. And the last one for this diagram, where does line HE, so that's this line going straight up and down, intersect plane GDF? Okay, yeah, it looks like at point E right there, they intersect. Right? The next 2, okay, we were using the idea that 2 pieces of a segment add up, make the whole thing. So that's where we said, well, this piece, AB, plus this piece, BC, equals the whole thing of AC. And we just plug in what we know. Right, so I know AB is 4.9. I know BC is 5.2. And then add them together, you get 10.1 centimeters is the length of AC. Okay. Similar idea for number 7. Okay, I'm going to say FG plus GH. So this piece plus this piece equals the whole thing. And then I plug in what I know. So this time I know that FG is 9.7. I don't know GH. And I know FH, the whole thing, is 15. So to solve for GH, I'm just going to subtract 9.7 from both sides and get that GH is, 5.3 centimeters, or not centimeters this time, millimeters. Okay, so make sure you're labeling your answers, right? If we're given units, put the units on there. All right. Questions on the first 7? All right, so then number 8 is pretty similar to numbers 6 and 7. We just don't have a diagram. So we have to start by drawing our diagram to model this situation. So what I'm told is that y is between x and z. Okay, so I'm going to have some line where I've got point y in between x and z. Then I'm given expressions for these pieces, right? xy is 2x plus 1, yz is 3x minus 2, and then the whole thing, xz, is 49. So I'm not told that y is right in the middle. I cannot just set these 2 pieces equal to each other. What I can say, though, is the same thing we said in the last problem. Right? I can say xy plus yz equals xz. This piece plus this piece equals the whole thing. So then I just plug in what I know. So xy is 2x plus 1, yz is 3x minus 2, xz is 49. So to solve this equation, combine my like terms over here. So we have 5x minus 1, add the 1 over, 5x equals 50, divide by 5, and we get x equals 10. Okay, the question says find the value of x and of yz. So I still need to plug this 10 back into my expression for yz. So yz is 3 times x, which we now know is 10, minus 2. So 30 minus 2 gets me 28. All right. The next one, finding the distance. Okay, well, we have a distance formula that you do not have to memorize. And this will be on the test tomorrow. You will have this. But this is the distance formula. Right? So what I need to do is label my points. x1, y1, x2, y2. And just plug these values into the formula. So this will become x2 is negative 1 minus 1 squared plus y2 is 4 minus y1 of 7 squared. So negative 1 minus 1 is negative 2. It becomes positive. So negative 2 squared is positive 4. Negative 3 squared is positive 9. So we end up with the square root of 13 for our answer. We could just leave it as the square root of 13, but if we put that in the calculator, I think it comes out to about 3.60. All right. Next one, finding the midpoints. Okay. You do not get the formula for the midpoint. Okay. So for number 10, we had our midpoint formula. It was just adding the two x coordinates together and dividing by 2. And then adding two y coordinates together and dividing by 2. Okay? We could also, well, I'll finish it out this way and then talk about something else. So I'm just adding the two x coordinates together. So my x coordinates are 1 and 7. Right? This is x1 and x2. So 1 plus 7 divided by 2. And then my y's are negative 3 and negative 7. So negative 3 plus negative 7 divided by 2. So 1 plus 7 is 8. 8 divided by 2 is 4. Negative 3 plus negative 7 is negative 10. Negative 10 divided by 2 is negative 5. Okay. We could also use Desmos to do this, right? We could plot these two coordinates on a graph, count the total x and total y distance between them, and find something that's exactly halfway. Right? The last one on the front here, number 11, we do want to use Desmos for. Okay. Okay. I'm just going to draw out a graph here, but the idea is, okay, we've got point A at 2, negative 1. So 2, negative 1 right here is point A. C, which I'm told is the midpoint, is at 5, 6. 5. So here's my point. So endpoint, midpoint, my other endpoint is going to be up here somewhere. Right? So all I need to do is count how far over and how far up I have to go to get from my endpoint to my midpoint. I'm going to go that same distance again to get to my other endpoint. Okay, so to get from here, I'm going over 1, 2, 3. Then to go up, I'm going up 1, 2, 3, 4, 5, 6, 7. Okay. So now I'm going to do that same thing again. I'm going to go over 3 and up 7. Okay, so when we have Desmos, right, all counting the boxes, right? So when I count those boxes, when I go over 3 and up 7, I believe I end up points 813. Okay. What's that?
I got 811.
Plus 7, plus 7. I think it should be 13.
You're probably right.
Well, so this point is at 5, 6. So if we're going up 7 from a y coordinate of 6, we would end at 13. Are we okay with that one? Alright, then on the second page, okay, we're starting fractional distance for the first couple of problems here. So the first two are just on a number line. The first step for fractional distance is to find the total distance between the points in question. So first I'm looking at A to F. So I'm starting at -5 and going to 4 of 9. Right? So I can say my total distance from A to F is equal to 9. Then I want 2/3 of that total is 9. You can put that in the calculator to get 6. So this tells me I want to go 6 spaces from where I started. I was at -5. So if I'm starting at -5, going 6 spaces, I will end up at 1. So we can do that mathematically, right? Say -5 plus 6 is 1, or we can just count that on the number line. Right? Start here and go 1, 2, 3, 4, 5, 6, and end up here. Okay? So x, this point they want to call x, is at 1. That would be my final answer. Right? We first want to find the total distance from A to C. So A is here, C is here. That total distance, 5 to -1, would be 4. I want 3/4 of that distance. So 3/4 of 4. And if we put that in the calculator, we get 3. So that tells me from my starting point, which was at A, I'm going to go a distance of 3. I would end up at -2. Or if we want to write that down mathematically, we could say I'm starting at -5, going a distance of 3, and I should end up at -2. Alright. Then, if we want to do that same thing on a coordinate plane, I'm just going to do that twice. So I need to find the total x distance between my points and the total y distance. So from M to N, right, I'm just going to count the x distance and then separately count the y distance. So from -6 to +6, that's a total x distance of 12. From -4 in my y's to +4, that is a y distance of 8. So I want 1/4 of that distance. Okay? So I'm going to start with the x's. Okay? My x distance, we said was 12. I want 1/4 of 12. So 1/4 times 12 is 3. So that tells me from my starting x value of -6, I'm going to travel 3 spaces. So -6 plus 3 gets me an x coordinate of -3. So I'm starting here, going 1, 2, 3. So my new x coordinate is going to be here at -3. The same thing for the y's, right? We said the y distance was not 12, it was 8. So then I want 1/4 of that total distance. So 1/4 of 8 is 2. Then I'm going to start at my y coordinate here of -4. I'm going up 2. So my new y coordinate ends up being -2. So this point right here, the point at -3, -2, is the point that's 1/4 of the way. So that's the answer. That coordinate point, -3, -2. Okay. Questions on fractional distance?
I always think it helps to plot your final answer because if you get something and you look at it and you're like, that doesn't look a fourth of the way up, or that's not even on the line, then you know you forgot a step somewhere.
Yeah, absolutely. Yeah, if you just get some numbers, let's say you stopped here and said, well, I think my answer is 12.8, right? Well, if you plot the point 12.8, that's way over here somewhere, right? That's not even anywhere close to the line. Yeah, so plotting your point, okay, your final answer should be a coordinate point. If you plot that, first, it should be on the line. And second, you should be able to kind of eyeball and say, well, yeah, that looks like it's about a fourth of the way from one point to the next. Okay. So the next couple were just about naming things in a figure, right, dealing with angles. So the first one, we want to name the vertex of angle 4. Okay, so angle 4 is this angle right here, right? Whenever I have a number inside of an angle, okay, it's right next to the vertex, so it's naming this angle here. So the vertex is just point T, right? I'm not naming the whole angle. In this case, I'm just naming the vertex. The sides of angles, okay, so this one we're talking about angle 5. The sides of angles are rays. So this would be angle 5 right here. So I want to name the two rays that create this angle. To name a ray, almost. That would be the angle. So to name rays, okay, we're naming each side separately. So I'm going to call this first ray, okay, this side, I'm going to call it TS. Could I have called it ST? Does that matter? It does matter, or I could have called it that. I guess I should have only asked. It does matter, right? We always have to start with the vertex. Right? So in this case, I could not have called this ray ST. Okay? It would have to be TS. The other one then would be TW, right? And then good. Right, and then the notation for a ray is that line with one arrow over top. Right? So we're starting at the vertex of the angle and saying the rays would be TS and TW. Last one for this diagram is just naming an angle. So this time we're looking at angle 3. So that would be this angle right here. Now remember, when we're naming an angle, we use 3 points and we put the vertex in the middle. So if I want to name this angle, I could call it angle WTV or VTW. Okay, those are really the only two options. And we do need to put that angle symbol in front. So WTV, or we could say angle VTW.
I said 1, 2, 3. 1, 3, 2.
So the numbers don't name the points. The numbers name the angles. So we can't really use those to name.
I didn't notice that.
There you go. Good job. All right. Any other questions on naming stuff here? All right, then the next couple deal with the idea of bisecting. Okay, so this was section 1.4. We looked at this. So what I'm told is that BA and BC are opposite rays. That means this makes a straight line. And then I'm told that BD, this ray right here, bisects angle EBC. If I know this bisects the larger angle, that means these two smaller angles that are created are the same. They have the same measure. So now, in 18, what I'm told is that angle EBD, so this little angle here is 4x plus 16, and then this angle, DBC, is 6x plus 4. I'm going to say those two would be equal to each other. So I set up 4x plus 16 equals 6x plus 4. Okay. Solve this equation. So you get the x's on one side. 16 equals 2x plus 4. Subtract the 4 over. 12 equals 2x. Divide by 2, and we get x equals 6. Is that my final answer? No. Right? The question says find the measure of angle EBD. So what I need to do is take my answer of 6 and plug it into my expression for EBD. So the measure of angle EBD will equal 4 times 6 plus 16. So that's 24 plus 16 would be 40. Then on 19, okay, we're dealing with the same diagram, so I still know that these two smaller angles are equal, but we're given different information. So now it tells me EBD is 4x minus 8, and then EBC, which is this whole thing, so the whole angle here is 24 degrees, right? This whole angle EBC is 24. So I think a lot of people were tempted to say, well, 4x minus 8 equals 24. That's not the case here, right? This angle isn't equal to this angle. But what I do know is if this angle is 4x minus 8, that one's 4x minus 8. So what we could do is say 4x minus 8 plus 4x minus 8 equals 24. There's another way that we could do this as well. Okay. If I know the whole thing is 24, and I know that that 24 degree angle is split in half, that means each of these smaller angles would just be half of 24. They would each be 12. So I could also say 4x minus 8 equals 12. I'll get the same answer when I solve either of these equations. Right? So if I solve this one, 8x minus 16 equals 24. Add the 16 over. 8x equals 40. Divide by 8. And x equals 5. I would get the same thing here. Right? Add 8 over. Divide by 4. And we get x equals 5. Okay, so either way we do this, we'll get the same answer. The question also says to find the measure of angle EBC, but that's kind of a stupid question because we're already told the measure of angle EBC is 24. Right? So we didn't really have to do any more work to find that second answer. Right? Questions on bisecting. All right, then the last page was our angle relationships from the last section. Okay, look at it. Vertical angles, linear pairs, and complementary angles. So in this first one, angles that are right across from each other are vertical. Right? Vertical angles are equal to each other. So my setup here would be to set those two expressions equal to each other. 9y plus 7 equals 2y plus 98. So then, get my y's on one side, get my numbers on the other, so subtract 7 over to the other side, divide by 7, and I think that's 13. Is that my final answer? Yeah, right, because it just says solve for y. So y equals 13. Be my answer. So the key here, vertical angles are equal to each other. For the next one, I've got a different setup, a different diagram. These two angles are right next to each other. They're not across from each other. And they make up a straight line together. Okay, that's a linear pair. Whenever we have a situation like that, the two angles would add to 180. So here, my setup would be 7q minus 46 plus 3q plus 6 equals 180. Combine my like terms, so 7q plus 3q would be 10q, Negative 46 plus 6 would be negative 40. Then I would add my 40 over to the right side. We get 10q equals 220. Divide by 10. We get q is 22. Is that my final answer? No. Right? We also need to find the measure of angle ABD. Right? So finding q was part of the answer. And then I also need to find the measure of angle ABD. So ABD was this one, the 7q minus 46. So I'm just going to plug 22 in place of q. So what is that? 154 minus 46 is 108. Thank you. Okay, so q equals 22, and the measure of angle ABD is 108. Would be my two answers for this problem. Okay, you okay with that one? So now the last three of these, we have x's and y's that we have to deal with. Remember, we can only set up an equation that has one variable in it first. Well, I'm told that this right here is a right angle, meaning these two angles together would be 90 degrees. So I can say 2x plus 40 equals 90. Solve for x, subtract 40 over, we get 2x equals 50, divide by 2, and we get x equals 20. Then to solve for y, well, if this is a right angle over here, that means this also has to be a right angle over here. So I can just say 5y equals 90, divide by 5, we get y equals 18. The next one, I'm going to use both vertical angles and linear pair. So on this one, it doesn't matter if I solve for x or y first on this one. It will matter on this one, but on this one it doesn't matter. So if I solve for x first, well, I'm going to look at the relationship between 2x minus 17 and 63. So I can cover up this top part of the diagram, right? I'm just looking down here, and I can see that these two angles together are a linear pair. So my setup would be 2x minus 17 plus 63 equals 180. Combine my like terms here. So negative 17 plus 63 is 46. Subtract my 46 over. We get 2x equals 134. Divide both sides by 2. And x would be 67. Then, to solve for y, well, I can say these two angles are vertical angles. So I can say y plus 23 equals 63. Then all I would have to do is subtract 23 and get y equals 40. You okay with that one? Then for the very last one, this one, I have two expressions that deal with x, and just one expression that has a y in it. That tells me I'm going to have to solve for x first. Okay? I can't set up an equation that only has one expression in it. So I want to look at the relationship between these two angles. They're vertical, they're right across, which means they're equal to each other. So I'm going to say 2x plus 5 equals 3x minus 33. So get my x's on one side, get the numbers on the other, and we get that x is 30. So now, to solve for y, I have to use that piece of information. Okay? So I'm going to plug 38 back in here for x. So 2 times 38 plus 5. So, what is that? 76 plus 5 is 81 degrees. So now, I know that this angle and this angle, right, since they're vertical, they're the same. I know these two angles are both 81 degrees. Now, if I look at the relationship between this angle and this angle, they're a linear pair. They would add to 180. So I can say 4y plus 1 plus, not plus 1, sorry, 4y minus 1, plus what I now know this angle to be, 81, is equal to 180. So combine my like terms here. 4y plus 80 equals 180. Subtract 80. We get 4y equals 100. Divide by 4. And y would be 25. Any questions?